Okay, here we go. 8, 9, and 11. So number 8. So we've got this this is the Spider-Man thing, right? So remember, if you have a, let's see if I can do this real quick. If you have a circle and you have, oh my word, that's a horrible circle. And you have an X in the middle, and this is A, and this is B, and this is C. Oh, please cooperate with me, computer. This is C and this is D. That you hit the one theorem that says, therefore, that A times B or AB is equal to CD. Okay. So in our particular scenario, we have that. It's just the numbers aren't very pretty, right? I'm still going to do the same thing. So let's see. X times 4.5 would equal 5 1/3 times 2 1/4. Now, remember, we can't multiply with mixed numbers. We need everything as improper fractions. So let's turn everything to improper fractions. Let's see. 2 times 4 plus 1 would be 9/2. 5 times 3 plus 1 would be 16/3. And 2 times 4 plus 1 would be 9/4. On the, let's see, the right side there, a bunch of things cancel. Let's see, the 4 goes into 4 once, 4 goes into 16 4 times, 3 goes into 3 once, and 3 goes into 3 9 times. So I'm just left with 4 times 3, 12. And then I do a copy dot flip. So multiply both sides by 2/9. So on the left side, everything cancels. You're left with X. On the right side, see, 12 times 2 is 24/9. And I think 3 goes into both 24 and 9. 3, yeah. 3 goes into 24 8 times, and 3 goes into 9 3 times. I think the book answer says 2 2/3 because they're just changing it to a mixed number. 8/3 is perfectly fine answer. All right, so there's number 8. Number 9, I want to get rid of this picture here. Let's see, erase, clear all. Here we go. So if you have this picture, remember, this is that one that says, let's see, what's the pattern? It's the whole darn thing times the thing on the outside is equal to this side. It's a tangent, this side squared. All right, so the whole darn thing would be X plus 3X, or 3X plus X. And the thing on the outside would be X. I've skipped a step. I'm gonna go back one. Yeah, so the whole darn thing would be 3X plus X, or X plus 3X, and the thing on the outside would be X. So that's what I've got there on the left side. On the right side, 10 times 10, 10 squared. Okay, so 10 times squared, 10 squared is 100. Let's see, distributive property, that would give me X squared plus 3X. Group the X squared and the 3X squared. That would be 4X squared. Divide both sides by 4, and then take the square root of both sides, and you get 5. Here we go. There's that one. The last one, it's proof. Looks like it's complicated. It's actually not bad at all. Let's see how this one goes. Well, let's see. We're given that UT is tangent at T, and we're supposed to prove that multiplication. Now, if you look at what that multiplication is saying, let me see if I can annotate it for you in blue here. It's saying UV is the thing on the outside, and then times UW. That's the whole darn thing. Well, that sounds familiar. And then we're supposed to prove that, let's say UX, that's the short piece on the outside. Oh, that's the same thing, except it's not the same. It's not the same triangle. It's a different triangle. So, I mean, it's two different circles. But if we just look at, let's say, I'm going to clear everything out here. If we just look at the circle on the left, including the T, and that. So that's all I'm looking for. Imagine that the other circle doesn't appear there. Well, then you've got a secant and a tangent. And remember, the pattern is the whole darn thing on the outside. That would be the whole darn thing. That would be UW times the thing on the outside. That would be UV. That sure looks, I mean, that looks a whole lot like what it says right there, except it's just written backwards. But then we have this tangent piece here, UT. So we have this one little tangent piece, UT right here. Well, we would just square that. That would be the pattern. So let's see, what would be the pattern? It would be UW. That's the thing on, that's the whole darn thing. That's from U to W times the thing on the outside. That would be UV is equal to UT squared. Now, if you look at, I'm going to erase everything. If you look at now ignore the circle on the left. So in other words, I'm looking from here all the way around. It's very similar. The whole darn thing would be UY, and the thing on the outside would be UX. That sure looks like what's written right there. times ut squared. And so I would get that statement. And well, those two statements are equal to the same value, ut squared. So we could use some substitution and set them equal to each other. The multiplication is commutative. 2 times 3 is the same as 3 times 2. So I can switch up UW and UV, and we get to our final answer. I'm not sure why I didn't put that in yellow, but I didn't write this as a formal proof, but those would be the steps. So the first two steps, you could write them actually as one step, and that's by that one theorem that says if you have a secant and a tangent to a circle, that the product of the length of the secant times the length of the segment on the outside is equal to the segment of the tangent squared. Then all I'm doing is a substitution and then just the commutative property, and that's how the proof would work. And there you go. There are all three problems.